Good morning and welcome back, and we are looking at linear inequalities this time, but we're looking at drawing multiples on the same axis by hand and then understanding how they're supposed to be shaded. So what I've got here is I've got a equation, and I'm going to write it out in blue. Y is greater than or equal to minus 2x plus 10. And I also have the equation y is greater than or equal to x minus 2. What I need to do is I need to sketch the region that is shaded by them. So I need to sketch the region. And then I also need to find the point of intersection. All right, so I need to find that point of intersection. So the first thing I'm going to do is I'm going to draw my lines. Now in both cases here, they are greater than or equal to, so I'm going to be using solid lines. So for this one here, I'm going to have an intercept at 10, all the way up here. Now I'm not doing this terribly accurately. And then when y equals 0, x is going to equal 5. So I'm going to have a line there. But then I have to make sure that I sketch the correct region. Yep. Now again, it's greater than or equal to, so not sure how I managed to do that. So there's my blue line. Now I need to decide, what am I actually shading? So again, this is where you do that 0, 0, the origin test. If I put 0, 0 into here, I get 0 is greater than 10. Is 0 greater than 10? No. Therefore, what I'm going to do is I'm going to highlight this part of my graph, because 0, 0 is not found in that region. I'm going to shade all of this. And now I'm going to move on to my next one. So when x equals 0, y equals minus 2. So that's going to look something like about there. And when y equals 0, x is going to be equal to 2. And again, because this is a double line, this is greater than or equal to, I can put the line right through there. Now all I need to do is decide what side of the line am I going to shade. Am I going to shade the left side or the right side or the top or the bottom, depending on what it is. And in this case, if I put 0, 0 into here, I get 0 is greater than or equal to minus 2. And is 0 greater than or equal to minus 2? So I'm going to include whichever side has 0, 0 into it. So that is all of this. So what I'm looking for is I'm looking for the region that satisfies both linear inequalities. What region of results satisfies everything that I need? All right, and it is going to be the area that has both orange and blue in it. So what I'm looking for is I'm looking for this wedge. Now obviously it's going to go off infinitely up that way and infinitely off up that way, but I know that that is the region that I want, because that's where both of my shadings overlap. If I was doing this on the CAS, it wouldn't draw any of that and it wouldn't draw any of that in terms of the colors. The other thing it wants though is it wants the point of intersection. So it wants that there. It wants that point of intersection. Now, the way we find that by hand is we make both of these inequalities just equals. Y equals minus 2x plus 10, y equals x minus 2. Because they've both got y in them, I can put them back to back. And I can say that x minus 2 equals minus 2x plus 10. And then I can solve for the x value that I need. So in this case here, I add 2x to both sides and I get 3x minus 2 equals 10. I add 2 to both sides, 3x equals 12. Divide both sides by 3, I get x equals 4. Now that only gets me 1 point, or one part of the coordinate. I now need to take x equals 4 and put it back into one of my equations. Y equals 4 minus 2, y equals 2. Therefore, the point of intersection is at 4, 2. And if I put this into the other one as well, it'll also be true. So 4, 2, and then when you are doing inequalities like this by hand and you need to communicate what you mean, what I would generally do is I would have a little key. And then you would just say, you would call this the feasible region. That's what the question is actually asking, and that's what the question is caring about. The word feasible will make more sense when we go into the applications of these. But again, what we're looking for is we are looking for a set of x and y values that satisfy both linear inequalities. And that is the areas that are double shaded with the blue and in the orange. And because of that, we've also found the point of intersection where the things overlap, and we have the boundaries for it. So let's take this one step further. We can have linear inequalities that have as many boundaries as we want. Right? So we can take these and we can add more and more restrictions to it. And each and every time we're going to be slicing off part of the graph that we either don't need or don't want. So in the case up here, and this is a case with a lot of feasible region questions, is that they might put in an extra region that simply just says x is greater than or equal to 0. And in the case of my graph here, if I was to apply that restriction to it, what am I now cutting off? Well, if I put this into place, then I only want values that are greater than. So I can now go in and I can, instead of doing, so I've got orange highlighter, I've got blue highlighter, and now I'm going to put some red highlighter in as well. It's a really colourful lesson today. And each and every time, I'm simply just changing what the feasible region looks like. It's all the different overlappings of colour. I could then go in and go, well, what if I say y must always be 10? So I go in and I say y must be less than or equal to 10. And I put, I should have done that in a different color. Yep. So y is less than 10. Now I happen to know where 10 is because I drew it before. And I put that 10 in there. And then I'm going to have even more shading to do. And that's going to mean that the only thing I care about is this tiny little triangle where everything overlaps. And when that happens, what I need to do is I need to find the corners, find the boundaries for my equations. So I've now got 4 different feasible regions sketched and shaded. And the only area that I care about is, I need to do this in yet another color. I'll do it in green. Is I care about this triangle here. So I care about this point here, and this point here. And I only care about the areas that are enclosed by that. So I've got a triangle here. Now I know where this point is. This is at 0, 10. I know where this point is, it's 4, 2, which is what I found before. But to fully understand what's going on, I need to find one last point here. And my question for you is, which equations should I use to try and find those points? Because 2 of these equations are going to give me the points that I need. If I find where these 2 points intersect, then I can find that last green dot. All right, so I've got an orange line here and I've got a purple line here. So when does the orange line and the purple line intersect with each other? So when does x minus 2 equal 10? That's obviously at 12. So this point here is 12, 10. So anywhere inside this boundary here is the area that I care about, and that's the area that I'm going to use. So as an example, let's move over to the CAS, because I'm sure you guys want to do work on your CAS instead of doing everything else the other way. So the question I'm going to ask you is, x plus y is less than or equal to 7. 5x minus 3y is less than or equal to 15. And x and y must be greater than or equal to 0. Now, the problem with what I've said is that they are still in intercept form. They're not in a form that my CAS can work with. So again, we have to go back here. So on your keyboard, under Math 1 is solve. It's also found under Math 3 because Math 3 also has your inequality symbols. So what I'm going to do is I'm going to do x plus y and make sure I use the correct symbols. 7, and I want to solve that for y. So I've got that one. And then I'm going to put in 5x minus 3y is less than or equal to 15, y. Now, this is what I was pointing out last video. See here, in this one here, it is pointing to the right. But when you solve it and rearrange it for y, it's swapped directions. All right, so that is why I suggest you use your CAS for this to help prevent these sort of mistakes. This flip happens when you divide by a negative number. All right, that's why. Because to rearrange this, I have to get rid of this minus 3y. But let's just use our CAS, let our CAS handle it. Those are the 2 things that we're in a graph. The other 2 restrictions, x is greater than 0, y is greater than 0, we can put those in ourselves. So, y is like that. So we're going to take that, we're going to drag it down there, click on the equals, make sure that we have our inequality pointing the right way. We're going to take our next one, drag that down, make sure we put the inequality pointing the right way. Now our next inequality is going to be x. We want x to be greater than or equal to 0. Make sure that all of these are ticked. And now we need to change this back to y is greater than or equal to 0. We press the graph and it draws all those lines in for us and only leaves us with the shaded region that we care about. Now, when you do these sort of questions in your book, they are going to ask for the corners, the corner points of the feasible region. So in this case here, this one here is pretty self-explanatory. This is 0, 7. All right, that's given to us by this blue line here. So when x equals 0, y equals 7. This red line here, we can clearly see that that's over 3. So when x equals 3, the whole thing equals 0. But the only one we don't know is this one here. Obviously, we've got 0, 0 here. So 1, 2, 3, 4. So we have 3 of the 4 points that we need to find. So this is the last one here. The overlap between the blue and the red lines. So I'm going to go analysis, G-solve, intersection. And it's going to have a bunch of flashing lines for me. So in this case here, the blue line is flashing. I want that blue line. I also want the red line because now they're both flashing the same color. And it tells me that it is at 4.5, 2.5. All right, so 4.5, 2.5. I would then, when I draw that graph on my book, in my questions, etc., I would label the 4 corner points, or all of the corner points. The more restrictions you put onto it, the more corners you're going to have to figure out the intercepts for. If I was to put a 5th one in here, then obviously I would have to rearrange and start adding extra restrictions in. But for now, this is pretty much what we need. So I've got a shaded region. Remember, if yours doesn't look like this, it may look like... So remember, your CAS may be set to union still. And if that's the case, it might look like that. And if it looks like that, I don't know about you, but where's the feasible region? I can't tell. Hit the cog, graph, change inequality plot to intersection instead, and it only graphs the important bit. With the important bit gone, with the important bit only visible, much easier to draw your graph. You now have enough to complete 23A, 23B, and 23C. We will continue on with 23D on Friday.